Alright, so let's moving to solve this problem. First of all, what we need is to jot down all the things that we know. So we were given the following is work of the turbine. So I'm going to use the work dot, meaning that it is in 210 megawatt, or you can write it as 210 kilojoule per second. So the dot here indicates time. Okay, so next you will give, this is an simple ideal Rankine cycle. So you quickly know that you are going to plot your TS diagram. So you are going to have a bell curve here, and that your Rankine cycle will be like this because it's an ideal simple case. Okay, so it's going to be a very straight line here, or should we make use of ruler instead? Alright, and this TS diagram is always equivalent to the schematic diagram that you have. So I'm going to print screen from your textbook. So represented in the left hand side is the schematic diagram that we have, right? Regarding your simple ideal Rankine cycle. So now we are going to label this TS diagram according to this schematic diagram that we have, right? So we have state 1, which is inlet to your pump, and state 2, which is outlet to your pump, and then state 3, going out from your pump into the boiler and going out from your boiler into your turbine. So this is actually the work of your turbine, and this is actually the work of your pump. Okay, so it is in a clockwise in manner, right? So this is finally state number 4. Okay, so we go through the questions again. You have the work turbine as 210 megawatt, and also it says here steam enters this turbine. So this is your turbine. Entering would be state 3 at 10 megapascal. So you quickly know that this is your high pressure, which is equal to your P2 and also equal to your P3 and equal to 10 megapascal. So whatever point that crossing all the way here must be in the same pressure. Okay, and it also says here that inlet to the turbine, the given temperature is 500 degrees C. So I'm going to take my ruler here. So this will give 500 degrees Celsius. Okay, and is cool in the condenser. So it goes down from the turbine coming to the condenser at 10 kilopascal. So this is your pressure low, which is equal to your P4 and also equal to your P1, and the reading is 10 kilopascal. Alright, so you need to show the cycle on TS diagram. This is exactly what we do with respect to saturation line. So this is the saturation line, and determine the quality of the steam. So what you will need to find, right, the quality of the steam at the turbine exit. So we are going to indicate the quality as X, and it is at the turbine exit, which is exit to your turbine, so it actually state 4. So the point is in here, right? So we label it as X4 for your A, and then for your B, we are asked to find the thermal efficiency of the cycle. Okay, so by now you should understand that thermal efficiency is going to express using this mathematical expression here. And C, what you need to do is you need to find the mass flow rate of the steam, which is your m dot. Alright, and the unit should be mass kilogram and flow rate is in second. Okay, so the moment you have this value, you already know that it has to be something regarding the flow rate or the mass flow rate. Alright, a quickly highlight over here. So you can see that this is the line of a constant pressure line. But however, if you have a look at the temperature graph over here, okay, so the temperature at this point, right, is not equal to whatever temperature in here, but the temperature at this line is the same, but the temperature at this point won't be the same. So if you drag along this line, you will see that you are going to have a different temperature. Okay, and it goes the same with the S value. So at this point, you are going to have Sg, saturated gas. At this point, you are going to have saturated liquid, and along this line, whatever along this line is going to be a mixture region, SFG, and the value is from 0 up to 1. If you need to recall back on your property table, you may do so by watching the playlist of the video that I have made in playlist Thermodynamics chapter 2. Right, now that we have all the property given and we already sketched our TS diagram, so let's start with the A part here. How are we going to find the quality of X4? So if you open up your textbook, alright, so you will see that the X value has been explained in chapter 3. So you go down here to 3-5 about property tables. So you can read through all the explanations on how are you going to get the X value, right? So basically the X value is a measurement of mass of water vapor divided by the total mass, right? So that's why if you read through the question, it says the quality of the steam at the turbine exit. So how much the steam has changed into water vapor with respect to the whole mass of the steam, right? So we scroll down here, so you will see all the mathematical expression over here, and finally you will have this form of equations, okay, and also this form of equations translated into this general form, okay, translated into this general form in order for you to be able to find the rest of the property in the property table. For example, let's have a look at the appendix 1 property table here for table A4. So that general equations, right, will be used to find all this value here: specific volume, internal energy, enthalpy, and entropy. Okay. So now I'm going to show you how this how these general equations can be used to find the value of specific volume, in enthalpy, and also your internal energy. U is regarded as internal energy. So we write down first the general equations that we have, right? So for A, okay, y is equal to yf plus x yfg, and the things that we are looking for is the x value, and it is at state 4, right? So you rearrange this equation, it becomes 1 minus YF over YFG, and all this reading must be at state 4 too. Okay, but what will be representing the Y? Are we going to make use of H? Are we going to make use of U? Or are we going to make use of V? Right, the inquiry in here depends on the informations that we have, right, that enable us to read the value from the property table. Okay. Okay, so given that this is in state 4, right, so what we do next is we try to jot down anything really related to state 4, right? So what do we know about state 4? So we have P4 is equal to 10 kilopascal, and that we know S4 is equal to S3. So means that why is it S4 is equal to S3? Because this is regarded as ideal, simple ideal Rankine cycle. So we assume that at the turbine state, there's no heat losses, right? There's no heat gain or heat loss. So basically, the steam that going out from your turbine, coming in from the turbine is equal to the energy going out from the turbine. Hence, there's no change in the enthalpy. We will see later how does the effect of heat in the turbine is going to have the actual ideal Rankine cycle. That will be our next topic. Okay, for now we are going to solve the simple part first. Now, the rule of thumb of reading your property table, you will need two known values. So now this is the only things that you know is 10 kilopascal, and there's another value which is S4, but we don't know what is the value. For further explanations, you can again go to this playlist here. You will see what are the rules of thumb in order for you to be able to read your property table. Alright. Okay, so moving back here, so since we don't know, we lack of information over here, so we are moving to the next state, which is your state 3. Okay, so when you go to state 3, you can see that we have P3, it's actually your high pressure, which is 10 megapascal. And also you know that the temperature at 3 is equal to 500 degrees C. Now 10 megapascal is also 10,000 kilopascal. Right? So according to the rules of thumb that are from the video that I have made, when given to you pressure and temperature, read it from table A6, where this is the superheated region. Right? So if you scroll upward, so you can see that this point is, yes, it is in superheated region. In fact, the water that drew inside your boiler have gained enough heat for it to change phase into steam, and now the steam becoming high pressure and high temperature. So next we are going to have a look at your property table. How are we going to read the table so that we can gain S3? Right? So we scroll down to table A6. Okay, and given to you 10 megapascal. So you will look through the pressure of 10 megapascal. Right, so here's the 10 megapascal. So we are going to look at what is the value of for 500 degrees C. So we highlight it here, and what is the entropy value, right? So what is needed is the value of entropy, or S. Okay, so S is seated in this column here. So at 10 megapascal with temperature at 500, so the value of your S is this one. So you copy that. So 6.5995, and please do not forget to jot down the unit. Okay, unit is very critical for engineers, right? Right, so now that we have gained the value of S3, so we can put the value into here. So your S4 now have the value S equal to S3. And remember, the objective is for you to get the quality of X, right? So we rearrange the value here. Okay, so how are you going to get the value for SF4? Okay, so given that SF4 is at 10 kilopascal, so you go to this property table. Okay, so it is table A5, right? Because if it's table A4, the first column is temperature reading, but the question only given you pressure, not temperature. So we are going to have a look at here. So we have this 10 kilopascal over here is equal to the following value. Okay, so what is needed is SFG and SF. So you copy back into your notes and make use of your scientific calculator to obtain this value. And again, what does this value tells us? It is actually the quality of X, which is the ratio of mass vapor to the total mass of this mixture. So if you open up your textbook again, under the topic of 3.5, which is saturated liquid vapor, so you can see the definitions of the quality of X over here, where the total is actually the mass of liquid plus with the mass water vapor. So you can see from the given problem that some of the steam has become liquid. Okay, so the next part is for us to solve this thermal efficiency, and it's going to be quite lengthy. Therefore, I'm going to solve this part on another separate videos. Thank you.